Okay, this is our second lesson for Module 6 in the IM1 curriculum. And today we're going to talk about right angles and how we know something forms a right angle. So the title is 6.2, Is It Right? And this is a Solidify Understanding task. We begin by stating a fundamental idea for our work. Horizontal and vertical lines are perpendicular. Do you agree with that? Picture a horizontal line, that's a line that lies flat in the plane, and then a vertical line going straight up and down. Now, would a horizontal line and a vertical line form a right angle? So let's see if we can visualize this. For example, on a coordinate grid, the horizontal line y equals 2. So picture y equals 2, and I see it right here. I'm going to highlight it. And the vertical line x equals 3. Okay, so the vertical line x equals 3 is this vertical line right here. And again, understand the x coordinate of every point on this vertical line is 3. And the y coordinate of every point on the horizontal line is 2. Now look at the angles formed right here. Okay, intersect to form 4 right angles. So know the symbol for a right angle. Here it is right here. And if this angle were 90 degrees, wouldn't this angle, and that angle, all 4 of those angles would actually be 90 degrees. So typically we'd only mark one of them. But what if a line or line segment is not horizontal or vertical? All right. How do we determine the slope of a line or line segment that will be perpendicular to it? So that is today's objective. And we have some pretty cool experiments. All right. So experiment 1. Consider the points A, which would be 2, 3. So that's this point A right here. And then B, 4, 7 would be this point right here. And line segment AB, and this is the notation for segment AB. It's this line segment on the coordinate plane right there. What is the slope of this line segment? Well, you guys know slope is what? Rise over run. Okay, so M equals, and the way we see this on a grid would be how far are we rising, and then how far are we running to get from one point to another point on the plane. Equals, now how far did we rise to get from point A to point B? We rose 1, 2, 3, 4 units. Oh, and let's visualize this with a slope triangle. You can see it a little better. So this distance is 1, 2, 3, 4. And then this distance right here, positive 2. So we are rising 4 units and we are running 2 units. Awesome. Now, let's say they just give us 2 points and they don't give us a graph. All right. That leads to our definition of slope. And so what is rise? Well, rise would be the difference between the y coordinate of the second point minus the y coordinate of the first point. So y sub 2 minus y sub 1 over, and run would be the difference in our x coordinates, and we call that x sub 2 minus x sub 1 right there. So what does that equal? Well, let's go ahead and write the coordinates of point A and point B. So point A would be the x is 2 and the y is 1, 2, 3. And for point B, the x is 1, 2, 3, 4. And the y is 1, 2, 3, 4, 5, 6, 7. All right. Now, make sure you understand what this notation means again. Y sub 2 would be the y coordinate of the second point, which is point B, and that's a 7. Minus y sub 1 would be the y coordinate of the first point, in this case 3. And then x sub 2 would be the x coordinate of the second point. That would be 4, minus x sub 1 would be the x coordinate of the first point, and that's a 2. And of course, if we simplify this, guess what we're going to get? 7 minus 3 is 4, and 4 minus 2 is 2. Now, 4 divided by 2, let's simplify that. So we have a slope of 2, implying segment AB, the segment right here, has a slope of 2. Every 2 units it rises, it's going to run 1. And then if we did that again, we end up at point B right there. So the slope is 2. Now, locate a third point C with coordinates x, y on the coordinate grid. So the points A, 2, 3, B, 4, 7, I'm glad those agree to our points right there, and C, coordinates x, y, form the vertices of a right triangle with AB, segment AB as its hypotenuse. So I see a right triangle in my picture right now with my slope triangle, but let's draw another right triangle below that uses AB as its hypotenuse, but we'll put C below segment AB. So I think C would go right here. And the coordinates of that point, did I write down the coordinates? I didn't yet, but again, let's look at this right here. Does this look like a right triangle? Is that a 90-degree angle right there with a hypotenuse, segment AB? I believe so. Okay, so that's a 90-degree angle. And what are the coordinates of C? Well, the x-coordinate is 1, 2, 3, and 4. And the y-coordinate is 1, 2, and 3 right there. Okay, and great. Now, C, 4, 3. Explain how you know that the triangle you form contains a right angle. Well, again, if we look at segment AC, that's horizontal. And then segment BC right here, that's vertical. And we just talked about how horizontal and vertical segments have to be perpendicular. So that's my explanation. Again, one more time. Segment AC is, and that's my horizontal segment right there. And segment BC is, well, here's my vertical segment right here. And this is a notation we're going to use in Module 4. That this 1 hash mark and this 2 hash marks means these 2 segments do not have the same length. All right, but we do know segment AC is horizontal and segment BC is vertical. Therefore, AC must be perpendicular to BC, forming that right angle right there. Check. Okay, now rotate this right triangle 90 degrees about the vertex point 2, 3. So we're going to rotate this entire right triangle about this point A, which has coordinates 2, 3. Explain how you know that you have rotated the triangle 90 degrees. Okay, well, let's think about this now. We need a direction if we're going to rotate 90 degrees, and it could be clockwise or counterclockwise, and because they didn't tell you which way to go, you could do either. So how about if we rotate about that point A, and let's rotate clockwise. So if we rotate clockwise 90 degrees, well, the first thing I would probably picture is, see this point C, or segment AC right there? If we rotate segment AC about point A 90 degrees clockwise, wouldn't this C, which right now is 2 units to the right of point A, end up being 2 units below point A? Right there. Okay, and now picture, where is this point B? And by the way, we call that now C prime. And now where would point B end up? Well, right now point B is 1, 2, 3, 4 units above point C. So if we rotate 90 degrees, wouldn't B prime end up being 1, 2, 3, 4 units to the right of C prime? There's my B prime right there. All right, and there's triangle ABC having been rotated 90 degrees clockwise about point A. It's beautiful. And we call this triangle A, B prime, C prime. Since A is also A prime here, again, The point that we're rotating about is my original point A, and that also can be considered A prime right now. Now, explain how you know that you have rotated the triangle 90 degrees. Well, let's think about this now. Okay, explain. Okay, well, AC is, and again, AC right there, that's horizontal. Segment AC prime is, that's this segment right here, and that's vertical, and we know that horizontal and vertical lines must be perpendicular. Check. Okay. 5. Compare the slope of the hypotenuse of the rotated right triangle with the slope of the hypotenuse of the pre-image. What do you notice? Okay, so let's talk slopes again. Okay, so let's start with, and this notation means the slope of segment AB. So that's our original segment right here, and we already know that we're rising 1, 2, 3, 4, and we're running 1, 2. And now let's compare that to the slope of segment AB prime. So if I'm going from A to B prime, I am rising -1, -2, and I'm running 1, 2, 3, 4. Okay, now what do you notice about these two slopes? 4/2 compared to -2 over 4. Well, you guys know what reciprocals are. Like the reciprocal of A over B would be B over A. So these two fractions are reciprocals, but one is positive and one is negative. So we call those negative reciprocals. The two slopes are negative reciprocals of one another. Okay, so that's a 90-degree angle right here, and then we have negative reciprocals right there. So I would conjecture that if I have two segments whose slopes are negative reciprocals, then those two segments would be perpendicular, forming a 90-degree angle, just like that. Okay, so we're going to make the conjecture that segment AB is perpendicular to segment AB prime. And the symbol for perpendicular is an upside down capital T, just like that. Perpendicular. And again, horizontal and vertical, perpendicular. Okay, now experiment 2. Let's talk slope. What is the slope of segment AB? Well, to get from A to B, rise over run, right? How far am I rising? Okay, I'm going to put my fraction bar this like that, and I am rising 1 unit up, and then how far am I running? 1, 2, 3, 3 units to the right. So the slope of segment AB is 1/3. Now add a point C with coordinates x, y on the plane to create a right triangle. So I need a right triangle. So you have two places you could put that. I think I'm going to put this C right here. Now, do you agree? C, which has coordinates now, let's see. The x would be 1, 2, 3, 4, 5. And the y would be 1, 2, 3. Okay. So, does that point C form a right triangle? Well, let's see. AC is horizontal. And there's BC. And segment BC is vertical. And we know that a horizontal line is always perpendicular to a vertical line. So that has to be a 90-degree angle. Okay? So, I'm getting a little ahead of myself right now. Now let's, just like last time, let's rotate your triangle 90 degrees clockwise about point A. So we're going to rotate about point A. That's my point of rotation. How many degrees and which direction? 90 degrees clockwise. So we're going to go this way. And that looks like a 90-degree angle right there. So if point C is 1, 2, 3 units to the right of point A, and I'm rotating about point A 90 degrees clockwise, wouldn't it end up being 1, 2, 3 units below point A? right there. So there's my C prime. Okay, cool. Now let's take the whole triangle here. So picture B now, which was 1 unit above point C. So when I rotate it, won't B prime end up being 1 unit to the right of C prime? There it is right there. And I have the vertices of my rotated triangle ABC. Right there. A or A prime, B prime, C prime. Okay, good. Compare the slopes of the hypotenuses of the pre-image and the image. Know this language. Pre-image means our original hypotenuse right here, and the image is after the rotation right here. Okay, so what's the slope of segment AB? Well, it is still 1 over 1, 2, 3. I'm rising 1 and I'm running 3. Now, what is the slope of A prime, B prime? And remember, A is also A prime because that's the point we rotated about. So this segment right here has a slope of, well, I'm rising -1, -2, -3, and I'm running 1. Now look at those two slopes, 1/3 and -3 over 1. Yeah, negative reciprocals right there. 1/3 and 3 over 1 are reciprocals. One is positive and one is negative. So we are conjecturing that those must be perpendicular. So I'm going to say that segment AB is perpendicular to segment AB prime. Okay, now, same experiment, they just changed our original segment again. So let's do the same thing one more time and make sure this continues to work. So what is the slope of segment AB? Well, looks like we're not going to put the slope triangle in. We're just going to think rise and run. So to get from point A to point B, I'm going to rise 1, 2, and I'm going to run 1, 2, 3, 4, 5. Okay. Now add a point C with coordinates x comma y to the plane to create a right triangle. So could I put my C right here? And that has coordinates 1, 2, 3, 4, 5, 6, 7. And the y coordinate would be 1, 2, 3. Okay, there it is. Now, explain how you know you formed a right triangle. Well, let's complete this triangle here then. So I need segment AC. And that segment AC is what? That's right, that's a horizontal segment. And then I have segment BC right there. And what is BC? It is vertical. And you guys know from the beginning of this activity, horizontal and vertical segments are what? Always perpendicular. So we know this must be a 90-degree angle right there. Okay, now I'm getting ahead of myself again. So now we're going to take this right triangle with hypotenuse AB and we're going to rotate it 90 degrees clockwise about point A again. So here's my point A. And if I rotate 90 degrees clockwise, picture this segment AC. Well, see that point C? If I rotate, C is 1, 2, 3, 4, 5 units to the right now. But when I rotate 90 degrees clockwise, won't it end up being 1, 2, 3, 4, 5 units below A? So that's C prime right there. Now picture point B. B was 2 units above C, so after the rotation, B prime would end up being 2 units to the right of C prime. And there's B prime. And now let's do triangle A, B prime, C prime. And again, you could call that A prime, B prime, C prime if you'd like. And does it look like the hypotenuses are perpendicular? Well, we've got the rotation. Compare the slopes of the hypotenuses of the pre-image and image. What is the slope of the pre-image segment AB? Well, again, the slope is I'm rising 2, and I am running 1, 2, 3, 4, 5. Now, if these are going to be perpendicular, then the slope of A prime, B prime would have to be, well, I'm dropping how far? 1, 2, 3, 4, 5. So that's a rise of -5. And I'm running +2. And look at those two slopes, 2/5 and -5/2. Those are what? That's right. Those are negative reciprocals. So we know that those two hypotenuses must be perpendicular. So segment AB is perpendicular to segment AB prime. And if you wanted to call that A prime, you could. Okay. Hey, looks like we're going to do this again. So we need the slope of AB this time. Now, I'm going to work left to right, what I typically do. So I'm going to start at point B, and I'm rising -1, -2, -3, and I'm running 1, 2. Okay, so add a point C with coordinates x, y to the plane to create a right triangle. So I think I'm going to put my C right there. Okay, and what are the coordinates? Well, the x coordinate of that point is 0, and the y coordinate is 1, 2, 3. Okay, so there's our point C of x, y, and the coordinates of C are x is 0 and y is 3. So, explain how you know you formed a right triangle. Well, let's draw our triangle then. That is segment AC right there. And AC is what? That's right, it is horizontal. And this is segment BC right there. And BC is what? It is vertical. And you guys know horizontal and vertical segments are what? They are perpendicular. Okay? So, now rotate your triangle 90 degrees clockwise about point A. So my point of rotation is right here, point A, and I'm gonna rotate 90 degrees clockwise. So that's gonna take this segment AC, and it's gonna rotate C, which is now 2 units to the left of A. And when I rotate 90 degrees, won't that C be 2 units right above A? And we would call that C prime. Okay, now picture B. What happened to B when we did this? Well, it was 1, 2, 3 units to the right of C. So that means B prime would have to be what? Okay, did I say that right? Now, B is 1, 2, 3 units above C. So B prime would be 1, 2, 3 units to the right of C prime, right there. And now let's draw our triangle. And there it is. Now, is that a perfect rotation of 90 degrees? I believe so. So let's prove that by comparing the slopes of the hypotenuses of the preimage and the image. So the slope of AB is, well, AB, what's my slope? I'm going to start at B. I'm rising -1, -2, -3, one more time. And I'm running 1, 2. We see that here. We see that up above too. All right. Now, how about the slope of A prime, B prime? Well, that would be this segment right here. And I'm rising 1, 2. And I'm running 1, 2, 3. And do you see negative reciprocals? I know I do. Therefore, those two hypotenuses must be perpendicular. And therefore, we've done a correct rotation. 90 degrees. So segment AB, let's find it again right here, is perpendicular to segment A or A prime, B prime. Okay, now based on experiments 1 through 4, state an observation about the slopes of perpendicular lines. I think we have this. Slopes of perpendicular lines will always be negative reciprocals of one another. While this observation is based on a few examples, can you create an argument or justification for why this is always true? Note, you will examine a formal proof of this observation in the future module. Okay. So, well, what did we do every time? Well, think about this. Slope is always rise over run. And we are saying that if we are perpendicular, then rise over run, well, what would the negative reciprocal of rise over run be? It would be the opposite of run over rise. Now let's take one of those segments that we were dealing with, and let's picture this right now. So picture your slope triangle right here. Okay, where to get from A to B, I had a rise, and then I had a run. Now, let's go the opposite of our run, and our run was 1, 2, 3, 4, 5. So now I'm rising the opposite of that 5. That means I'm going to drop negative 5. 1, 2, 3, 4, 5. There's my negative run right there. Okay, and what was my rise? 1, 2. And now that becomes my rise, which is 1, 2 right there. Okay, and that gives me this point right here and that segment right there. Now, do these look perpendicular to you? They certainly do to me. So I think we have a great conjecture that segments with slopes that are negative reciprocals will always be perpendicular. Wow.